Look at the purpose of the quadratic formula. In order to use the quadratic formula, we have to make sure our quadratic is in standard form, okay? And this is our standard form. It's written as some coefficient of a times x squared plus some coefficient b times x plus some constant term c, okay? And the quadratic formula will solve the x-intercepts for you. It'll also help us move from standard to factored form. And factored form really does the same thing. It helps us find x-intercepts very quickly. So let's keep in mind an x-intercept is where a quadratic will cross the x-axis, okay? And they're commonly referred to in the factored form as the r and the s. That's the actual x-intercept values, okay? It's possible to have no x-intercepts. It's possible to have one x-intercept. It's possible to have a max of two x-intercepts because we have a parabola, okay? And I'll quickly show you what those would look like. I'll throw them up here. One with no x-intercepts would be something that either starts above and goes upwards or starts below the x-axis and goes downwards. And you can see it never crosses. Okay? Something with one x-intercept would be where the vertex is directly on it. So like this or like that. Okay? So the vertex is directly on it, so that's one. And something with two would be something that crosses, like this or like this. Okay? Does that idea make sense? This is where you'd get 0. These guys is where you get 1. And these guys have 2 x-intercepts. Does that make sense, that idea? Yeah. Okay. So, like I was saying before, we have to be in standard form. And let's pull out an equation. You know what? Here we go. So we stole this question out of your textbook. And it's a trinomial, so there's 3 terms. And it's in standard form. In order to use the quadratic formula, we have to be able to tell what the a, the b, and the c is. And it would be the same idea with factoring. Our a term is the coefficient in front, so it's just 14. The b term is the coefficient in front of x, so it's negative 31. And the c term is negative 10. Okay, it's important that we're able to do that. So the quadratic formula, like we said, will help us find x-intercepts, which can help us build our factored form, okay? So one way we could do it is by factoring, and there's many different ways of factoring. They use sum and product, decomposition, you have tons of names. So sometimes they don't always work. The quadratic formula will always solve it, no matter what it is, whether it's decimal values as your x-intercepts or their whole numbers, which is usually easy to factor. We're going to take these values and we're going to plug them into this formula below. So, let's take a look here. What it's saying is x, and this is saying both the x values. That's why it's set equal to x. It's the x-intercepts are equal to negative. What's our b value here? What's it say?
Square of b squared.
Oh. Well, just this value here.
Oh, 31 and x.
So negative 31. Okay. So I replace the b value with negative 31. Okay. And it says plus and minus because there's a possibility that we'll get 2 answers. So we have to add and subtract. The square root of, we already know our b term again. It is negative 31 squared. Okay, so we replace the b minus 4 times the a value. The a value is 14. Times the c value. The c value is negative 10. Okay, and then again, all of that is divided by the number 2 times a, and our a value was 14. So a lot of stuff to memorize, this quadratic formula. There's a ton of numbers in it, okay? So now we just kind of follow our BEDMAS to figure out our final answers. So x is equal to negative 31 will become positive 31. Good. Plus or minus the square root of. Okay, so you've got some big numbers underneath here. So let's take out a calculator. See if it can't help us out. We have 31 squared. Okay, 961. So negative 31 squared, we know it's a negative times a negative, so it'll be a positive, so 961, okay? And here, I want you to think of this negative 4, think of it like negative 4 times 14 times negative 10, okay? And because of the associative property, what that means is I can multiply in any order. Let's make this easy for ourselves. What's negative 4 times negative 10?
Negative 40.
It's going to be 40. Positive 40. Great. So now we have positive 40 times 14. And we can just plug that right into our calculator, right? So 40 times 14 equals 560. Great. And because it's positive, okay, because it's a positive value, we're going to say plus 560. If it was a negative value, we would say subtract. Okay, so we have to keep that in mind. And then we're going to be dividing by 2 times 14 is going to be 28. So all divided by 28. So it's getting a little better. We're going to deal with this square root. So the rest of the stuff's going to stay the same right now, plus or minus, and the square root. So we've got to add these together. And it looks like it's going to be the square root of 1, 2, carry 1, 1,521. All of that divided by 28. Okay, so we got to find this square root. Not a value we know off the top of our heads. Maybe you do. We take square root of 1,521. Hey, perfect. Became 39. So this is going to work out really nice. We're going to get some integers, which means we're going to get whole numbers. So x is equal to 31 plus or minus 39. Okay, divided by 28. So this is where it becomes important. Because it's plus and minus, we're going to get 2 answers. And just like if you're factoring, a lot of times there's 2 answers to it. We're going to split this equation. Okay, so we're going to say x is equal to 31 plus 39 over 28. And we're going to say x is equal to 31 minus 39 over 28. Okay, so we're getting 2 answers. So now we got to continue this using these 2. X is equal to, this becomes 70 over 28. And this becomes x is equal to negative 8 over 28. Is that correct? Yeah, I believe that's correct. So we got fractions, which would be really exact, but because we probably mentally work a little better at decimals to find out where the value is, let's go with our 70 divided by 28. 2.5. Great. So one of the x values is at positive 2.5. And then negative 8 divide 28. Let's see. 8 divide 28. And we know it's going to be a negative. Oh, there's an ugly number, but 0.28. And we'll round it to 0.29. Okay? So x is approximately 0.29. Now, to be as exact as possible, we should technically keep it as a fraction. Okay? So that's great. What that's just told us, okay, is that there are 2 x-intercepts. One of them is at, oh, and I should write this was technically a negative. One of them was at 2.5, okay? And the other one is at negative 0.29, okay? Great. Let's go back to the original equation, way up here at the top. The a value was a positive, so we know it opens upwards, okay? So because it opens upwards, we know we have some parabola that does this, okay? Excellent. So we've figured out some important parts. We don't know the vertex yet, but that's okay. This is essentially the point of the quadratic formula. It's to find the 2 x values. Now, how can we use that to go into factored form? We can. The factored form, as we talked about before, was y is equal to, sometimes they don't write that a there, but a x minus r x minus s. What are the values of our r and our s? What are the 2 values?
2.5
Yeah.
and negative 0.21.
Yes, excellent. And it doesn't matter which we call r and which we call s. So let's plug them in for our r and our s. So y is equal to, we still have that a value, x subtract 2.5, so I plug in 2.5, and x subtract negative 0.29. Okay. Let's simplify those brackets. Y equals our a value. This becomes x what? Plus or minus 2.5?
Minus.
Yeah, that makes sense to us, right? A lot of times, if you remember when you're factoring, it's the opposite term for the x value. And what about this one? X plus 0.29. Okay, important. Are we done the factored form? Have we figured out all the variables?
No, we didn't figure out a.
A. A is really, really simple. Let's go back up. What was the a here?
14.
14.
X.
Yeah, we only use the coefficient, so just 14. So y equals 14 x minus 2.5 x plus 0.29. Now, you may not be used to writing factor form in this version. A lot of times teachers want like 2x plus 3 4x minus 5, whatever it is, and they don't have an a value here. But this is the exact same thing. Okay, so it's really important that we realize that. Let's say you had factored this the normal way by decomposition or something. You would have actually got this as a factored form. And this one that we got with our quadratic formula is technically the same thing, but they look very, very different. Obviously, this one has a decimal, this one has a decimal, and really we should have wrote the whole decimal, whereas the fraction we got, which was -8/28. But anyways, and there's no a value in this version. So we need to prove this to you, because you may not believe this. But if we take a look, here's our standard form. It was 14x squared minus 31, 10. There it is in black. Our version, and again, we rounded this value a little, but as you can see, it goes right above our red one, right? And that's really the value we could have used. And then the normal factored version is right above that too. So both of these are technically factored form. It doesn't really matter which one. You know, your teacher might be a little specific, but there's nothing wrong with this version that we use the quadratic formulas to. And a quadratic formula is always straightforward, plug numbers in and work on a formula. Sometimes easier than remembering all of our factoring rules.